Okay, hello everyone. Thank you very much for coming. My name is Joel. I'm a Symfony developer currently working at Runroom. And today I'm here to talk about the EventDispatcher, the natural successor of hooks. And if there's anything that I would like you guys to remember from this talk, it's this. Hooks must die. All right? Why am I saying this? Currently, in Drupal, we have two ways of managing events. We have hooks, and we have the EventDispatcher, of which we're going to talk about now. And since they both do basically the same thing, eventually one of them will have to disappear. And I have strong reasons to believe that hooks are the ones that are going to go away in the future. And I'm going to talk about that. I'm going to talk, first of all, real quick about what hooks are, how they work, and some of the problems that they have. And then we will talk about the EventDispatcher. We'll see how it works, and we'll see how we can implement it, how we can use it in our own projects. So imagine the following situation. Imagine that you have a friend called Peter, and you want him to tell you when he leaves the office, so you can prepare for the meeting that you guys have. This is a simple diagram that showcases what's going on. Basically, when Peter leaves the office, he will have to call each and every one of the friends that have told him to warn them when he leaves. So in this situation, Peter leaving the office is a hook that is being invoked, or in other words, is an event that is happening. All right? So in Drupal 8, if we want to invoke a hook, we need to retrieve the module handler service, and we can call either the invoke call method that we have here or the invoke method. The invoke call has the advantage that it invokes the hook for all the modules that implement it. With the invoke method, we would have to specify which module do we want to invoke to. And this method takes two parameters. The first one is the name of the hook that we want to invoke. And the second one is an array of parameters that the hook requires. So in this example, we don't have a second parameter because this hook doesn't require any parameters at all. On the other hand, me preparing for the meeting is a hook function that is being run after the hook has been invoked. Or in other words, basically this is me reacting to the event of Peter leaving the office. So in order to register to a hook, we need to implement a function, and the name of the function is especially important because it needs to follow a convention in which the first half of the name has to be the name of the module, and the second half needs to be the name of the hook that we actually want to register to. So there are a few problems with this approach. The first one are the naming conventions. We are forced to follow that convention in order to register to a hook. We can't just put whatever name we want to put to the function. The second problem is that because of that, we need to write one different function for each different event that we want to register to, instead of just having a single function in which we can register to everything that we want, as we'll see with the EventDispatcher. And finally, there's a problem with coupling because there's coupling in the name of the function, because the name of the function needs to have the name of the hook. But also there is coupling in the parameters of the hook, because the piece of the code that is invoking the hook needs to know the parameters that the function that is registered to that hook has. All right? But this is not even the worst of it, because it's not only that hooks have those problems, but also the future of hooks is uncertain because they may die in the next version of Drupal. As we can see in this issue in the Drupal site, the conclusion that the Drupal team has arrived is to postpone their decision on whether to continue or not using hooks to the next version of Drupal. So for now, we have hooks and we have the EventDispatcher, but in the next version, we don't know what we're going to have. We don't know if hooks are going to continue. On the other hand, the EventDispatcher is very likely to stay with us because the Drupal team has made such a tremendous effort in including Symfony components into the core that it's not realistic that they're going to throw that away. It's very likely that the EventDispatcher is here to stay, and hooks, on the other hand, we're not so sure about that. In fact, some hooks have already been removed from Drupal. The hook menu, for example, has been replaced by the routing component, which is a Symfony component. And the hook boot, hook init, and hook exit have been replaced by kernel events, which are events that are also defined in Symfony and to which we can register to with the EventDispatcher. So the alternative to hooks is, as we already know now, the EventDispatcher. And this is a Symfony component, along with many others that now Drupal has in its core. And for those of you who don't know Symfony, well, who doesn't know what Symfony is about? Everybody knows Symfony, right? OK, everybody knows it. OK, well, in that case, I won't waste too much time here. Only I'd like to say that in Symfony we have some of the components of Symfony are not only used in Drupal, but also in many other frameworks, such as Laravel, for example, or PHP BB. OK, so the next question is why Symfony? Why did the Drupal team decide to include Symfony components into the core? They could have just built their own from the ground up, for example, or include others. But they went with Symfony, and the reason goes back to the Web Services and Context Core initiative for Drupal 8 that took place 4 years ago. It's an event in which these people gathered and discussed the future of Drupal. And here you can see some of the top developers of Drupal core. And especially this guy right here, his name is Fabian Potencier. I hope I said that right. And this guy is the lead developer of the Symfony project. So these people met and they discussed the future of Drupal, and they decided that Drupal, for the next version, needed to support web services. And in order to support that, the Drupal team had already some ideas on their mind on how to do that. But when they heard about Symfony, they realized that all that they wanted to do, Symfony had already done it before. So they came to the conclusion that there was no point in reinventing the wheel, and they decided that the way to go was to include Symfony components into the core. So this is the formal definition of the EventDispatcher that you can find in the official site of the component. And notice that the keyword here is communicate, because the EventDispatcher, after all, is a complete implementation of the mediator pattern. So imagine that you have a small application with just a few classes and very little dependencies. And then you start working on your application, and the app gets bigger, and you add more classes and more dependencies. And you end up having a system that is so highly coupled that it's very difficult to touch something because something else is going to break. If you're in that situation, the mediator pattern can be a great ally, because this is a mechanism that facilitates the communication between the different components of your application. So with the mediator pattern, basically you have colleagues and you have mediators. And colleagues are essentially all the classes of your system. And when a class wants to communicate with another, they don't do it directly. What they do instead is they rely on a mediator that is an intermediary that manages the communication. And you can create intermediaries for the whole set of classes or for a small subset of classes, whatever you may need. So the EventDispatcher is simply a concrete implementation of this pattern. As we can see in this diagram, the EventDispatcher itself is simply a big mediator for the different components of our system. And you can see that we also have subscribers and we have events. So when a class wants to register to an event, it notifies the EventDispatcher, and it tells it that it wants to be notified when a certain event happens. So when that event is being triggered by another class, it sends an instance of that event to the EventDispatcher, and then the EventDispatcher takes that event and it sends them to all the subscribers of that event. So this is the same example that we saw before when we were talking about hooks, but now it's applied to the EventDispatcher. So Peter leaving the office, in this case, is an event being triggered. And on the other hand, me preparing for our meeting is a callback function being run when the event happened. So it's basically the same thing, but there's a slight difference, and that is that Peter now has a secretary. So this would be a new diagram. You can see that when Peter leaves the office, triggers an event, so it sends it to the secretary or to the event dispatcher, and the event dispatcher notifies all the subscribers of that event. In this case, John would get the instance of the event, but Mark would not. All right, so these are the components that the event dispatcher provides. First of all, the event dispatcher itself, all right, the big mediator that we already know. Then a basic event class that we can use to trigger our own events, or that we can extend to create our own custom event classes. And finally, we have the event subscriber interface, which is, as you can imagine, is an interface that needs to be implemented by all the classes that want to subscribe to an event. So the next question now is, why should I use the event dispatcher, right? Well, first of all, the event dispatcher solves all the problems that we saw when we were talking about hooks. Hooks have naming conventions. The event dispatcher has no naming conventions. You can use the names that you want for the functions and the classes. With hooks, you need to write a different function for each event. With event dispatcher, you can have a single function in a single class that registers to all the events that it needs. And the event dispatcher provides some decoupling, because with the event dispatcher, we have an intermediary that is between the class that triggers the event and the class that subscribes. So the class that triggers the event doesn't need to know anything about the class that is subscribed to the event, and the other way around as well. But there are two more advantages. The first one is portability. Since the event dispatcher is a Symfony component, and it's being used not only in Symfony and Drupal, but in other environments as well, the code that we write with the event dispatcher can be easily brought to many other environments and ecosystems. So there's not that direct dependency to the ecosystem that we're working into. And the other advantage is scalability. Since we have an intermediary now, we can use some tricks in order to grow bigger and more complex applications, such as, for example, queuing events, or even using cache in order to store repetitive events and gaining some performance on the process. OK, so that's all the theory. Now let's see some code. We're going to see two use cases of the event dispatcher, which are the most basic. We're going to see, first of all, how to subscribe to an event, and then we will see how to trigger our own events. So how to subscribe to an event? First of all, we need to create a custom event subscriber, and then we need to register the event subscriber as a service. So to create a custom event subscriber, the first thing we need to do, as we saw before, is we need to implement the event subscriber interface. And then we need to implement the function getSubscribedEvents. This function, basically all it does is it creates an array of events, and then it returns it. As simple as that. So here we can put as many events as we want, and as many different callbacks to the same event as we want. This is the most simple example. We're registering one callback, which is that array, to one event. But if we want to register more, we can have an array of callbacks, for example. And for each callback, we need an array with two values. The first one is the name of the function that we want to run when the event happens. And the second one is a priority number. So basically, the higher this number is, the sooner this callback will be run. And now all that's left to do is to actually implement the callback function. So this function takes up to 3 parameters, although we only need the first one in most cases. The first one is the instance of the event class. And the second one and the third one, we can add them if we want. The second one is the name of the event, and the third one is the event dispatcher itself. So this is the step 2. This is where we register the event subscriber as a service. And in order to do that, first of all, we need to have a file in which we will register all the services of our module, which will be named with the name of our module .services.yml. Right? This is YAML format. And this is a very simple service. All right? Here we have the machine name, in this case, my module Office subscriber. We have the class that implements this service. And this is very important because we are registering an event subscriber. We need to add the tag event subscriber to this service. This is important because the event dispatcher, when it's about to dispatch an event, it retrieves all the services with this tag, and it sends them the instance of that event. So the second use case would be how to trigger our own events. And in order to do that, first of all, we need to get the event dispatcher object. Then, in case we need to, we would have to create a custom event class. And the step 3 would be to trigger the event. So step 1 is to get the event dispatcher object. And we can do this in 2 different ways. We can do this statically, as we can see in this example. Or we can do it by just injecting the event dispatcher into the class, into the constructor. The second step is optional, and it is to create a custom event class. And this is only necessary if we need, for example, to pass data to the subscribers. That would be a case. Or also, it would be necessary if we need to add some complex logic inside the event class. But if we don't need either of those things, we could just use the basic event class and dispatch the event. And this is the final step, and it is to actually trigger the event. And in order to do that, we need to call the dispatch method of the event dispatcher. So this method takes 2 parameters. The first one is the name of the event that we want to trigger, and the second one is the instance of that event. And finally, this method returns the instance of the event after it has been processed by all the subscribers of that event. OK, so I went really fast, actually. I'm realizing that. That's pretty much what I wanted to talk about. Let's recap a little bit. Hooks, we know what hooks are. We know the problems that hooks have. And we saw also that the future of hooks is a little bit uncertain because the Drupal team hasn't made up their mind just yet on what to do with them. But we saw the alternative. We saw that the future of Drupal is tied to Symfony, and we saw the event dispatcher component, which is the big mediator that manages the communication of the system. And we saw how it works, and we saw how to implement it, how to use it in our own projects with the code examples that we just saw right now. So now it's time for us to start using the event dispatcher in our own projects. And in order to do that, I've put here 2 links that I think you may find useful. The first one is a blog post in which you will see a brief introduction to some of the new features of Drupal 8. You will see the event dispatcher is explained, the dependency injection component of Symfony, the routing component, blogs, forms, and a few more things are explained. And the second link is a GitHub repository in which you will find the full code of that post. So again, now it's time for us to take action. Now it's time for us to start using the event dispatcher in our own projects. And it's time for us to kill Captain Hook once and for all. Thank you very much. Now, I know I was fast, so maybe you have a lot of questions. Here I am.
Well, can you summarize what are the reasons they gave to delay the decision for Drupal 9 instead of Drupal 8 point something?
Well, my guess is that they weren't
read through the issue or something.
No, yes, they decided that in this version, basically, they're going to see how do hooks and the event dispatcher coexist. They're going to test it out. They see how the community responds. They didn't want to make such a huge change just yet. They want to see how the event dispatcher behaves and how does people react to it. And
but can we have, like, for an event, like an invoke and an event dispatch for compatibility, or yeah, that's too much?
you could mix them if you want. The thing is that hooks are still needed for most of the system events, all right? But the event dispatcher can be used for your custom events. You won't have any problems there. So that's pretty much it. If you want to start using the event dispatcher, you can try it out with your own events. With the events of the system, we still need hooks.
The problem is the hook alters, no? From mostly, and that's what I heard. So the hooks that alter stuff, the hook of alter.
Yeah, those are very sensitive hooks, and well, they decided, well, let's let it like that for now. Let's leave it like that for now.
So the event dispatcher is currently not being used in the core, or is?
It's included into the core, and it's up to us to use it or not. It would be a good idea, in my opinion, to use it in our own events, in things that we can control. In events of the system, as I said, there's the problem that we still need to use hooks, but it's included into the core, and you can use it right away.
Can we use the event dispatcher in Drupal 7, or is it recommended?
I don't think so. It's included directly in Drupal 8. It's not in Drupal 7. Maybe if you can configure it somehow, you may use it, but I don't think so.
Is in Drupal 8 also the concept of subscriber and listener, different like in Symfony project?
As far as I've seen, there's only the concept of subscriber. They're telling you that you should create a subscriber class, because you can, in Symfony you can also use listeners. Listener is you should call the a method of the dispatcher which is @listener, and it's more like in low level, or no, not low level. It's more the subscriber. The advantage of a subscriber class is you have that organized in the same class. You have what you need. Listener is like, well, right now I need a listener. I add it right away, and that's pretty much it. In this case, all the docs you will find are talking about subscribers. No more questions? Well, okay. Thank you very much for coming.